To realize our idea of using I sub phi as approximate to a positive linear functional, the following lemma plays a crucial role. We'll call this the lemma 2. We'll show that I sub phi is approximately additive in the following sense. If f1 and f2 are non-negatively compactly supported on G, and phi is a strictly positive function that is compactly supported on G, namely in CC plus G. And epsilon is any positive number. Then there exists a neighborhood V of E, namely the identity element in the group G, such that I sub phi of f1 plus I sub phi of f2 is less than or equal to I sub phi of f1 plus f2 plus epsilon. And you should note that at this point we already have the inequality along the other direction. Namely, we already have I phi of f1 plus I phi of f2 greater or equal to I sub phi of f1 plus f2. This is due to our lemma 1, part C. And how is this neighborhood V of E relevant? This neighborhood V will be associated to phi in the following way. That this inequality holds whenever the support of phi is contained in V. Of course, for this green part, you don't need this condition. This is always true. So this lemma tells us for any small positive number epsilon, we can make I sub phi of f1, I sub phi of f2 as close to I sub phi of f1 plus f2 as we want with respect to epsilon, as long as this function in the subscript has a support contained in some pre-given small neighborhood of the identity of the topological group G. And now let's prove this lemma. The proof will be a little bit long, but this lemma is really, really important in our construction of Haar measure. So let's first single out the special case. If it turns out that f1 plus f2 is equal to 0, because f1 and f2 are non-negative, this means they are both 0. In this case, this inequality trivially holds, because this guy will be 0, this guy will be 0. And now, if f1 plus f2 is non-zero, namely, their sum will be strictly positive at some point, because they are already non-negative number. If they are non-zero, then the sum could be strictly positive at some point. Then it follows that the support of f1 plus f2 is non-empty. Notice that by assumption they are compactly supported. Their support being non-empty will provide us with a bump function on the support. So what I mean is that by the Existence Lemma, you can find this lemma in Fowler's real analysis. Second edition, page 137, the section 4.32, that there exists a compactly supported function g such that g is equal to 1 on the support of f1 plus f2. You can find this function thanks to Existence Lemma. Next, we let delta be a positive number to be specified later. And we set h be f1 plus f2 plus delta times g. And we put h sub I to be such function piecewisely defined. It is f sub I divided by h on the set where g is strictly positive and 0 on the complement of the support of fi. So this is for I equal to 1 and 2. And the next question to ask will be, are those HIs continuous and compactly supported? And of course, first you have to worry a little bit about its well-definedness on the overlap. So let's check them. The first thing we want to observe is that we really defined h sub i's on the whole group G. Namely, the union of those two guys will be equal to the group G itself. And why is this so? This is because if you look at the complement of this, because G is always non-negative, when you take the complement, it will be G equals to 0 intersection the support of Fi, which is empty. This is because we set G equal to 1 on the support of F1 plus F2. And the support of F1 plus F2 actually contains the support of the individual Fi. This contains the support of Fi. So in particular, on support of Fi, G is equal to 1, not 0. So their intersection must be empty. And now let's look at what's going on in the intersection of those two sets. Hi must be well defined on the intersection. And on this overlap of G greater than 0 intersection, the support of Fi complement H sub I, which by the definition on the set where G is greater than 0, so if x is in this intersection, then hi of x is equal to fi of x divided by h of x, which is 0. So those two definitions agree with each other on the overlap. Now, by the gluing lemma in general topology, we have h sub I in cc plus of g I equal to 1, 2. Actually, the gluing lemma tells us that hi is continuous. And hi is compactly supported because fi is compactly supported by our choice at the beginning. Hi is also clearly non-negative, and it can also be strictly positive at some point because of definition here. What you do is just that you choose a point where f sub I is strictly positive, and that strictly positive number will be divided by another number that is non-zero. So in the end, you will get the quotient that is strictly positive. So h is also strictly positive. This should be obvious for you to see. And now, if you know a little bit more about real analysis and topological groups, you will see that those hi's are not only just continuous on G, but also uniformly continuous. And we will write this as a claim. This is a very general result, and we're gonna write this into a lemma.